Hello and welcome to this new video. Today I will continue the series on the basic cases for the training you can do for Microsoft Excel World Championship. And again, Harry Seiders was so nice to develop 4 free cases to practice your skills and get a general understanding of the rules of the games as well as the mechanics for some common patterns you will need to solve during the competition. In this episode we're gonna tackle the map case, which is the third of 4 cases he has provided. So I just logged into the platform and downloaded the case, which I will go into now solving. So maps are a very general and common concept that comes up during the competition. You can see this is an example. For example, you have this island with animals, trees, things, and so on. The road, beach, land, water. Then also fish, ducks. So it's a very fun situation, and also opens up very interesting logics that you can apply into Excel in a very uncommon way. So let's go directly into the solve. Level 1 asks you to count how many times the following items appear on the map. Do not count the items in the map legend, of course, so just the things you have here. What I will do to avoid switching back and forth the worksheet is to give a name. So map. Which is probably not a very good name to use, because map is also an Excel function. So let's call it island map, which is better. So this level is about countifs. So the general idea is to apply the countifs function that can be applied also in a grid, so not only in a column or to a row. So what can I do is directly perform the countif. I suggest to use the countifs every time because it's free to add more parameter to the logic. I will give it the island map, and then I will give it the item itself. One thing you can notice is that you can basically provide those icons or items directly into formulas. They will be automatically recognized as unique sets of text or codes or whatever by Excel. So you don't really need to take care about any kind of weird conversion to, I don't know, symbols, because another idea could be to say, let's substitute every palm with A, every trees with B, and so on. What they usually do in the competition is also to provide an alternative to the map, which substitutes icons and items with letters or codes, in case you have any troubles in visualizing those symbols. Anyway, level 1 is gone. Bonus question 1, hard. Okay, how many ducks are on the water? Did you know that you can do a find replace based on the cell formatting? Before you try anything, make sure you have a copy of the map. So he's basically suggesting to make a backup. There are plenty of ways to do this. For sure, I think it's a good idea to duplicate the map. First idea that will come to my mind will be to cancel out, which is probably a bit slow, everything which is on the island. You need to be careful not to cancel also other things. Okay, and then you could probably run, also because you risk to mess up those answers because those are still formulas. It asks how many ducks So you need to do a countifs again. This time this is the range you wanna take, not the previous one, and the duck. So the answer should be 20. Another idea would be, let's restore the map entirely. Another idea would be to do what Harry is suggesting. So what you can do is running a find and replace. So you can run a find and replace of duck, but also picking a cell format and replacing, for example, with duck DW, which is duck water, and you can see I've made 20 replacements. So you can also do a countifs of DW. You will end up with the same exact thing, and so you can see that's it. Okay, level 2, indirect function. Indirect is a very powerful function which enables you to pull an information or the content from a given cell. So for example, I can say indirect U13 will return me the content of cell U13, and you can also direct it into other worksheets. So it's a pretty long name, so I will call this map sheet. And what you can do is basically say indirect, it asks for a text, so you will need to put into quotes map sheet, and then an exclamation mark, and concatenate the cell itself. So basically what I'm doing is the question is asking for U13, of course, into the map. So I could do this manually. U13, it's this one. And you can see that the syntax is map sheet exclamation mark U13. So I'm basically replicating the exact same thing here. And you can see the result is exactly that, but avoiding pointing every single cell one by one to their respective contents. And so that's our answers for level 2. Level 3 asks you to determine how long it will take Hannah to get to the following locations. She can only move north, south, east, west. No diagonals, and travels 1 cell per minute. She will always start on cell S9. Do not count the start cell in your calculation. So if Hannah went from S9 to S11, she will have moved 2 cells, not 3. Okay, so you basically have a starting cell which is S9, and you have an end cell which is this. So how do you do this? Basically, you can notice that you make one step either when you change column or when you change row. If you change both, this will count as 2 steps because we don't have the diagonal. So what I usually do is I convert those addresses into rows and columns indexes, and the simple way to do this is leveraging again the indirect function and the row function. I'm suggesting to use rows and columns, but I think he was referring to row and column, because if I do, for example, row of this, Excel will tell me this is row 117, which is exactly the row I'm in this moment. I'm interested in actually doing this in S9, actually, doesn't matter which worksheet. So leveraging the property of indirect, I can write something like this, and you can see I extrapolate the 9. Another way, of course, would be to say right of this of 1, but what happens if you have, for example, AH13? It's no longer right of 1, it will be right of 2, but starts to become a little bit tricky. You can write a function to extract the numbers from a given text, and then with those numbers you can substitute those numbers to the full string and just obtain the letters, so the column. It's a bit tricky. I suggest you to use this approach, so row of indirect and also of course column of indirect. And you can see you have row 19, which is column 19, which is the equivalent of column S. And then you do the same thing. Maybe let's compress a bit those cells, point this to the proper cell address, and then you are good to go. So this is row column, this is row column, and so the difference will be absolute value of this minus this, and same for the columns. And again, I'm going to resize a bit those cells. So this is row difference, and this is column difference, and I'm just gonna take the max of those, which is 1, and so I should be good to go. I think I can copy down all those formula and have my answers here. Bam. So for example, AH6 from S9, so AH6, it means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, which is wrong. Interesting enough. She can only move north, south, east, and west, now diagonal centralis 1 cell per minute. She will always start from S9. S9 to S11 is 2. S9 to S11. 1, 2. Okay, yeah, clear. AH6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Why on earth this is giving me 15? Yeah, because it's the sum of those. Apologies. Otherwise I would have used diagonals, so I need to move effectively 15 steps on the columns and 3 steps on the rows. So G9 for example is 12 because it's just steps on the columns. Okay, should be good to go now. And in fact max is introduced here. Harry was suggesting to use the let function, which I already showed you in the previous video, so not gonna leverage it for now. Felt going in 4 directions was too slow. Now she can move in all 8 directions, determine how long it will take Anna to get to the following locations. So it's basically the same exact thing. So here, except that now I for real need to take the max of those, I think. So in this case is 1. In this case is 15, so from AH6 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so 15 steps. I think we're good to go. So the idea is yes, you have to move 3 cells in the rows, but you will do that while moving also on the columns. So that's why the bigger of those two numbers will win over the other in terms of counting the steps needed. In this case, steps equals time because it's 1 cell per minute. Okay, data table. We already used them in the last video, so not going to provide any additional explanation. From the new starting position listed, find the closest banana, and I can move in all 8 directions. Have Hannah go to that banana and then go to the bear. What is the total time Anna traveled to the banana and to the bear? Okay, so banana locations are those. Okay, so they're not in the map. And then to the bear. Okay, V14. Okay. Okay, I will do the same thing which I did previously, and column of indirect of this. Okay, then same thing for the probably good to resize a bit this one. Same thing for the starting location, so row of indirect of this and column of indirect of this. Yeah, I'm suggesting to use a data table, which probably is a good idea. Yeah, I will take Harry's suggestion. So change my mind. Let's say I want to solve for example 5. So I'm going to XLOOKUP example 5 here, and I'm interested in the parameter for example 5, so K25, which has a row of indirect of this and a column of indirect of this. Okay, so this is the row and the column. Then what I could do is maybe transpose this thing here. So this is giving me the possible bananas, rows and columns, and I will compute the distance for everyone, which we know is the maximum value of the absolute value of this minus this, and I could do probably this to leverage dynamic arrays, and also the absolute value of the column minus the column's values. So this is not working, yeah, because the max is not giving the result I was expecting, so I will have to do this the old way. I want to lock column here and column here, and so this is those are our distances from those bananas, which makes sense because 20 is quite close to 25 and m is quite close to k, so it turns out this is distance, this has distance 5, while the other ones are at a longer distance. What we could do is say, look, I wanna find the closest one, so I wanna XLOOKUP 0, which is for sure less than any possible distance. XLOOKUP 0 into that, returning that, and I want the next larger item. So this gives me M20. Otherwise I could have done like a min of this, then xlookup in the min into the cells if there are no ties. Same thing here, because if there are ties you're gonna take the first one you encounter. So M20 is the next cell, and I need to know that, because on M20 I'm gonna do usual thing. So I could do row of indirect, column of indirect. I could also do xlookup of M20 here, returning this, so I don't have to recalculate, and it's just one formula, spilling, because it's an array. And then I need to calculate the distances from V9. It was, I think, no, V14. So V14, which, oops, as I'm gonna shrink a bit everything, okay. So V14, and then I'm gonna take the max of the absolute value of this minus this, and the absolute value of this minus this, which is 9 plus 5, which is 14, and it matches the example, luckily. So I'm gonna do I'm gonna take the mean, because I don't have the number, I already M20, and then I'm getting my 5 plus 9. And then I'm interested in solving for all the cases of, the games of level 5. This is the shortcut to put in the data table, column input cell, example 5, which is our parameter, updating the data table. And those should be the answers for level 5, hopefully. Level 6, offset. Offset formula returns a reference to a range. Okay, so basically, I will show you in a second how many ducks are within 2 cells of the following location. Hint: the height and width portion of the offset function is key in this task. So you're given with K25. You wanna see within 2 cells of the following location. So basically you go into K25, doesn't specify whether these 2 cells are with diagonals or without diagonals. So the example is K25, which is this, and within 2 cells we have, I think, this kind of square, this, which gives us 1 duck, but I'm not sure. Yeah, I think that's the standard definition of within 2 cells. So to have this kind of result, we're given with K25. If we're gonna replicate here, you can say offset of let's say K25. You can say offset requires rows and columns that you need to move from your starting location, and then height and width, which is how big horizontally and vertically, vertically and horizontally you would like your range to be. The tricky thing here is that we are given the center position of the range, so we're gonna move towards the upper left edge of this square, because then height and width will help you to form a square starting from the upper left corner. So what we're going to say is K25 minus 2 in the rows means up by 2, because plus 2 goes down. Columns minus 2, so 2 to the left. So I'm moving one cell, 2 cells up, 2 cells left. And then I'm going to say 5 by 5, which gives you the same exact square we should have here, like this, I think. No, like this. Yes. You can see the duck is 1, 2, 3, 4th row, first column, the palm here, 2 trees here. At least if this kind of interpretation is correct. So what you can do here is doing the same thing. So you will do the offset, but you do the indirect of map sheet, because you're gonna go into the other worksheet, concatenating this, and then you do the same thing, minus 2, 3, 3. Sorry, 5, 5. Sorry. Yeah, 5, 5. Okay. You notice you're spilling a range, so you're gonna go into trouble. If I wanna copy here, I'm going to have errors, so the spill error. But I can do a countifs directly here. So I'm gonna count here for duck. So I'm gonna just going to take the duck lock, and that's it. But I'm not sure about the results of this level, because I'm not sure about how big the range needs to be done if considering diagonals or not. Because if I don't consider diagonals, I will just have within 2 cells. I mean, otherwise I would have a weird shape, not a square. And then we go into the last level, which is the very hard one. So forbidden knowledge, you're given a certain location and the map symbol that you must travel to. You can only travel on the road. What is the quickest time possible while staying on the road? Your travel at the same speed as Anna, 1 cell, 1 minute. For this you will need to leverage circular references, which are a very dangerous and also powerful tool that Excel provides. Otherwise there is no way you're gonna solve this in Excel. Let me show you how it works. So I'm gonna make a copy of this again. Let's call it C for copy. Don't need this. I'm gonna get rid also of these coordinates here. So the idea is to have a starting location, so Z8, which I will pull through a data table. So I'm gonna say example 7, XLOOKUP this into example 7. Oops. Returning this. I'm not sure I understood the question. I don't understand what is the ending location supposed to do. You can travel on the road. Okay. Okay. So those are unique, I think, positions. That's pretty advanced. Because first of all, I will need to I will need to locate where this symbol is on the map. I could do that manually, to be honest, because one way to do this is just going straight here, clear format, find next. So this is Z5. Then this, the hospital, I think it's this. So S21. Oof. Then I have this, which is P26. Same. Then I have again the hospital. It's probably better to do something like this. So unique gives you okay. So Z5. S21, B26, AC17, E6, and AK5. So this is the manual way, not too time consuming since there were only 6 items. And so you have the ending locations basically, because then you can XLOOKUP here. Another way to do that, which implies the usage of another function, is to do something like this. I could do a toCall of the map, which basically transforms this into a single column going left to right and then up to down. I could say I will need to build also the addresses, which is probably a bit complex. So if I say let rows being row of indirect of this, then columns, column of indirect of this, and then you say address rows columns for that's quite interesting. So I don't get why I'm having those errors, to be honest. Because I have a lambda to do this usually. So now you can see the problem of having too many lambdas is that you forget the basics. That's interesting, because the idea was to build again a single column with all the addresses and look up the symbol because it's unique into the address, and you will have avoided the manual configuration. Now I notice this. arrow formation fish chasing the duck, chasing other fish. That's the genius. I'm curious to understand what the hell is going on here. Maybe I don't need the indirect. Yeah, okay. It was a stupid one. I of course don't need any kind of indirect because I'm directly referring to the range. So okay, that would be the other way. I'm going to call that, and then I would have my my symbols. So I'm gonna X lookup the symbols into this thing here, returning this thing here. And you can see I get the exact same result without having the manual configuration. But for the sake of solving, we said we start from Z8, we end in we don't know what, but that's an X lookup of this into this, returning from this. Okay, but I cannot calculate, of course, the distance between those two cells because I will need to consider the road. So that's where the circular references come into place. What I'm gonna do is something very tricky, because I'm gonna write a function which says if address of row, which gives me the current row, column, which gives me the current column, 4, which is the relative reference, equals to my starting position. I want to have 0 because that's the starting cell. Otherwise, I want to have the minimum of everything which is around me, diagonals excluded, plus 1, and that gives me 1, of course. Why I'm doing this? Because if I'm in starting cell, I want to count it as 0, of course. Then I want to basically increment by 1 every cell which is near to the previous one. And so with this logic, by simply copying this, you can see I go into troubles. What? That's quite interesting. That's probably because those are treated as codes. If I delete all of these things, I was not expecting this at all. Yeah, but of course I have the circular references enabled, so that's a problem of circular references. If I do is number this false. Well, I could manually delete all of these symbols. Of course, I've already saved, or potentially could delete everything. Just get rid of everything. We'll get rid also of this. So again, if address of row, column, 4 equals the starting value, which is this, then you give me 0, otherwise you give me the minimum of this, sorry, this, and this, plus 1. Okay, and then I'm gonna this is having a weird behavior, to be honest. Sure, circular references are enabled. Yeah, they are. Okay, probably didn't need to cancel the thing. So in this case, I'm interested in Z5. You can see Z5 is here. So I will probably need to go also on these spots. Because now the thing I can do is just taking the indirect into map sheet C, exclamation mark, and this, and you can see I'm given 3 as an output. So if I go for level 1111, I have 26, which is S21, which is this. Okay, I think that should work. I'm gonna apply the data table again. And in theory, I should be good to go. Doesn't look like a good solve, but yeah, I need the data table because I need the G7 to change, so that's quite an issue. Just run another update of the data table. Which is taking forever to do. It's oh. That might be a problem. Okay, finished calculating. Okay, now for some reason I perform the data table. I probably add the wrong parameter specified, and it should be it. So hopefully I'm not out of time. Okay, I'm not. Let's paste the answers into the platform. So one code, answer question 1, level 2 code, wow, with colors, level 3 code, level 4 code, level 5 code. As always, I suggest you to do this along the competition. Level 6 code, lots of zeros. Okay. And level 7 code. Fingers crossed. Okay, I have errors actually. That's very interesting. have a lot of wrong answers in level 7. So 26 for 101. Yeah, actually it is 26. So my data table is not working. Now you can see something is wrong with the data table. Can't actually understand exactly what. Because if I take the last one, 130, the answer is 10, which is correct. So the logic, of course, is correct. It's a problem of the data table, which is not updating properly. I don't know, to be honest, what the hell is going on. Let's try again to update the entire thing. Okay, apparently this recalculation worked, so this should be correct now. I need to paste again everything, which is pretty annoying. So level 1, I run the update of the entire workbook as opposed to the worksheet, which is probably the reason why I was having issues. Level 4, level 5, level 6, and that's it. Okay, now we're gone. Okay, that was a really nice and informative one. In the next video we'll go with the index X match, so the last one of this series. Hope you enjoyed this video, and we'll see you in the next one. Bye.